Hey everybody, this is Larry. This is day 27 of the Leetcode Daily December Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. It's going to be, what is it, 3 more, 4 more, 1, 5 or 6 more until the end of the year. I cannot count clearly. But maybe I could count this farm though. Let's take a look. 1578, minimum time to make whoop colorful. Okay, that is a nonsense statement, but let's keep reading. This has, I don't know, I'm a little bit chipper today. I think I finally slept enough, but still have a little bit of jet lag. So we'll see what happens. And it says, and balloons are arranged on a whoop. You're given a 0 index string colors, where colors are biased the color of the eye balloon. Alice wants the whoop to be colorful. She does not want 2 consecutive balloons to be of the same color, so she asks Bob for help. Bob, can we move some balloons from the whoop to make it colorful? You're given 7 index away of needed time, where needed time is the time in seconds that Bob needs to remove the eye balloon from the whoop. Return the minimum time Bob needs to make whoop colorful. Okay, I mean, I don't know. But it just seems like I don't know about the statement. I mean, but it seems like basically you don't want 2 consecutive balloons to have the same color. So basically, another way of saying it is that for a group of the same color balloons, you just want to keep one of them. There are probably a couple of ways to write this, but yeah, it's all going to be just linear time, constant spacey things. If you're lazy, you can maybe do constant space. Oh, sorry, linear space. But I mean, I think it's fine either way, right? So basically, yeah. Yeah, I mean, I think you just right. It is going to be greedy, right? And by greedy, I mean that for a collection of balloons that are consecutive or adjacent, I guess is probably the better word. But for all the adjacent balloons or collection of balloons where they're the same color, you just take the one with the, I guess, the maximum time to keep and remove all the other ones, right? So yeah, so basically, yeah, I mean that's pretty much it, really. Where n is length of colors, right? And then basically, if just trying to think what the cleanest way to write it is, but I don't really think. I mean, I think if you're just careful, it should be fine, right? If there's a 0 and color sub I is equal to color sub I minus 1, then what do we do, right? Basically, what we want to do is so if it is not, then we do. Okay, so if the same colors, then we keep one of them. Or we have to choose whether we want to keep. Otherwise, it erase. Otherwise, that means that we're at the border and or the thing, so then we don't do this, right? So max is you go to needed time sub I, because that is basically the max that we're keeping. And then otherwise, if they are the same color though, because if they're different color, then you don't remove this one, right? Because this is the first balloon of a new set of colors. Otherwise, then yeah. Otherwise, you want to see if needed time sub I is greater than max. Then we say, okay, well, first of all, maybe not first of all. At the end, we set max is equal to needed time. But before that, that means that we're going to remove max, right? So total we add max, and that's pretty much it, I guess. Because then now you do this, and then at the end, I think this should be good, but maybe I'm missing like an edge case, which I am apparently. Output 1 expected 2. Yeah, I'm kind of, I don't know how I missed this, but no, I mean, wait. Okay, so you move this one, so it gets 1. Or you move it when you get to 2. Okay, fine. The next one is 4. Oh, I guess I forget an else here. Otherwise, you just remove this time, and I think that should be fine. Right? Yeah. Am I missing a case? Yeah, let's give it a submit. It's very easy to miss a case, to be honest, so wouldn't be surprised. At least the way that I wrote it. To be honest, this is linear time, constant space is very cool. It's just like I said, right? After you formulated the problem, there's so many ways to kind of write this. You can write however you like. And I try to keep this linear time, constant space. But honestly, if I were to write this in a more, like if I was in competitive or something like this, I would probably just do linear time, linear space, or maybe even just pass another scan or something. Because this kind of, you have to really think for all the states that can happen. If I were to kind of guess, I would have done something like, maybe I would have done zip and group by together or something like this. So then maybe I would have something like, you zip colors and needed time. And then now you want to do group by. I forget how to choose the group by key. Is it just key? Something like this, right? And then now you have for do in something like that, maybe. Let's see if this, well, something like that, maybe. I forget how it goes. I'm just kind of returning some random junk just to see if this compiles. I say compile, but yeah, okay. I mean, I guess that's actually impressively. I mean, I'm impressed by myself, which I don't know, because I did not expect this to work like that. Is what I mean. But yeah. But then now you can just write something like right? We want to basically add the sum of v minus the max of v, right? Just one max, and that's pretty much it. And this looks, I don't know if this works. Sum of v, because it's not v, it's x for in v, and same here, x for because it has the color in the v. Max is an empty sequence. Can that be true? How can that be true? Oh yeah. That's what I was saying that I was worried about, because it's an iterator, so you can't do it twice. But then I got distracted by rewriting this part that I kind of forgot about it, to be honest. But yeah, so as long as you cast it to a list, it's okay. That's one of the caveats that you have to do, and then that's pretty much it. Because you're just summing it minus the max, it's the same idea. I mean, this is a little bit slower because technically you're kind of scanning it twice, so it's 2 loops, even though it doesn't look like it. I guess 3 if you count the max, actually. I didn't. That was just a little bit lazier on my part, but nonetheless, yeah, very easy to write, but and in a way, maybe except for the thing, it's just less error prone, right? Because it's more expressive as to what you say as opposed to this iterative stateful account. And this is the power of functional programming to some degree. What did I do before? Oh, I guess I did it the same way before. Kind of different, weirder state. And before that, I did more. I guess I keep track that way. That's kind of cute. But yeah. Anyway, those 2 ways are the ways that I have it now. This is the kind of linear time, linear space way, because we have to kind of do this. And also, I mean, even if we don't, I guess technically if you do iterators, is it so linear space? I actually don't. I guess maybe not. It may not be linear space, but SIP I think may be linear space anyway. No, because it returns iterators, and the point of iterators is that they're not. But still, I just went, yep, never mind. It is going to be a linear space. So yeah, And you know, this is going to be constant space if you prefer it this way. Let me know what you think. Yeah, that's all I have for today, though. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.